I wanted to give you a brief run-through of the basic story of why the Industrial Revolution happened in England in the 1750s instead of elsewhere. We talked about how the conditions of capitalism, private property, firms, and markets, we talked about how that institutional environment allowed individuals to pursue ideas and keep the benefits of having a good idea for themselves. So there was a lot of incentives to pursue good ideas, and firms allowed the pursuit of ideas on a bigger scale with more protection against personal risk. Anyway, we add on to that story of capitalism from chapter 1 in the Core-ECON text to modeling what exactly is going on, and that's what I wanted to talk you through. This is the first 2/3 of chapter 2 in the Core-ECON text. We start by examining technology, and technology is just depicted as all the possible ways of making, in this case, 100 square meters of cloth, which of course was a big important product in 1750s England. We talked in class about why C and D are dominated. There's ways, these are all the combinations that can make 100 square meters of cloth, and there's, B uses less of both factors, A uses less of both factors than C, B dominates D. So you'd never consider C or D. We talked about that. We're going to get to this point, as you remember, where B at prevailing prices initially is going to be the best way of doing things, and I'll talk you through why that is when I get to isocosts. I'm sorry. Anyway, these A and D, E, these other possible ways of making cloth. It's not that necessarily people knew about them, but it's that they could be imagined given prevailing technology in the 1750s. So there was some ability to burn coal to fire machines, but coal was really expensive. I wanted to tell a little story about today, right? We just to try to give you some story that might make more sense given today's world. So there's a big, huge steel plant down in McMinnville. It's a really neat plant, Cascade Steel, and it's got a direct power line from Bonneville Dam. They buy their power in bulk because it's costs so much there's so much energy required to make steel. Well, companies could make steel by powering their machinery by nuclear power plant. I mean, that technology, it's not that anybody's ever done that necessarily, but it could be done given what we know about nuclear, given what we know about the production of steel. Why doesn't anybody do it that way? It's just because the cost of nuclear is so high that why would you even try? But if we imagined a situation where somebody made just through developments in the nuclear industry that were unrelated to steel, let's say it became feasible, they figured out how to do fusion and contain the energy, and it became feasible to run a mini nuclear power plant in the part of McMinnville without risk of catastrophic nuclear meltdown. And let's say that technology emerged, became cheap and feasible. Well, it's not necessarily that anybody had run a steel mill off of a nuclear plant, but if that development happened and all of a sudden it became cheap, it would make sense for someone to say, hey, instead of paying Bonneville Power Administration all this money and buying this power that used to be the cheapest way of doing things, but now given this emergence of mini nuke plants, again in my imagination, geez, maybe I ought to try doing that. And there'd be this incentives. If I could make a ton of steel for $30 instead of $60, whatever the price of steel is, well then I would make an extra $30 a ton on my steel production because I've lowered my cost. So there'd be this big incentive in the forms of the higher profits I would earn because I figured out a way to sell the same amount and same quality of steel at a much lower price than everybody else doing it. So that would give me the incentive to try. Sometimes I'd be wrong, but in my firm that I'd start would be wrong. It happens all the time. But if I'm right, man, I'm going to be rich. I'm going to be the next Bill Gates or whatever. So to this analysis of production, we add information about costs. And there's just a bunch of isocost functions all throughout this. And firms, remember, if they make more money if their costs are lower, all else equal, ceteris paribus. The way we think about costs is, let's think about all the combinations that would cost 100 pounds to make. Pounds per day, pounds per week, I can't remember. Anyway, what their units were. But the cost would be the wage rate, which is 10, times the number of workers we employ, plus the price of coal, which is given at 20, times however many tons of coal we would use. Now, it's a little bit awkward, that form, because we've got essentially R, well, not essentially, actually, R on the vertical axis and L on the horizontal, and this isn't really the form that of a line that we use for this construct. So we solve for R, so 20R, I'm just making up one the total cost would be 100. 20R would be equal to 100 minus 10L. If I divide through by 20, I end up with this equation of a line that we're used to working with in this XY space, this labor coal space in this case. So R is equal to 5 minus L over 2. Now, that would be this line that would run like this. And that would be one isocost function. That's supposed to be a straight line. I'm not the best artist. I've just demonstrated. Anyway, there's all these. If the costs were a little bit higher, it would be up like this. All these costs functions. And let's say we were just by accident up at some point like F here. Well, the innovation rents in that case would be for firms to, I think the one at 80 runs like that, would be to say, hey, if we're at F, I can make money by using a slightly different combination of labor and coal and get to B, and I can outcompete all my competitors because I've got lower costs. And everybody would see that and imitate. And that's not the basic story. That would have happened before whatever the innovation rents came to be. So that's the idea of these isocosts and how we get to B. The market pressure pushes firms to be to choose the technology that's the lowest cost. All right, so far so good. Just to pretty it up, I've got the textbooks story. Well, now comes the event, and for whatever reason in the economy in England, there were actually two events. We're going to model just one of them to keep within the ceteris paribus assumption. But what happens is that factor prices change. They discovered a bunch of coal in England, driving the price of coal down. We saw that the wages of spinsters rose really fast. We're going to assume wages to be constant, but let's say P falls from 20 down to $5 a ton. And that's dramatic change. Well, initially everybody's still making coal with technology B because that's what they know how to do. So, initially everybody's on a higher isocost line. We could write the equation for that. We're at B, so 4 times 10 is 40, and 2 times 5 is the new price of coal is 10, so we're at an isocost of 50. Okay, that's cheaper than 80, and everybody's producers are happy. But what this does is it creates this opportunity for somebody that's pretty clever to say, hey, you know what? Coal is so cheap, and I see the way they're powering these machines off of coal and saving labor effort, making the same amount of product with more machines and less labor. I wonder if I could come up with a way of making 100 square meters of cloth using this energy intensive way of production instead of labor intensive, relatively labor intensive, and that creates this opportunity. It'd be like if the nuclear technology changed in today's world, and initially everybody's still running their steel plants off electricity, but somebody says, hey, I bet I could build a little mini nuke plant next to a steel factory and power it that way and make more money. And if they're right, they make more money, and maybe they patent that plant. And so for a while, the government protects their sole possession of that technology, but that patent expires and everybody imitates, or they sell the rights to build the plants that way and make money not by making steel, but by selling the idea of how to make a little mini nuke to power a steel plant. So in this case, this creates this opportunity for somebody to say, hey, I bet I could invent a machine that ran off energy and coal, and only one person would be required to operate it, and that I could, at today's prices, I could reduce my costs even still further below 50, down to, say, I think in the end we end up at 40. Let's see, A is 1 times 10 is the wage rate, plus 6 times 5, that's the price per coal, that's 10 plus 30, that's 40. So I could make an extra 10 pounds for every 100 square meters of cloth, and I'm making thousands of square meters of cloth. So 10 pounds really adds up fast. So if I'm the one that thinks of that, I make money. That's the payoff. These changing factor costs, and of course in this environment where there's a lot of innovation happening in other fields, too, makes this very fertile opportunity to imitate what's going on elsewhere in the economy and bring it into a new application and find a way to make more money. And that's the incentive that drives this constant cycle of innovation. And here's just the pretty graph of that final case. And now everybody's making it. There's an incentive for everybody to shift to A over time instead of being stuck at B. The firms that are still using technology B are going out of business because everybody else has 10 pounds per 100 square meters of cloth cheaper costs, and they're just going to make more money, and you're going to make less, and you're going to go out of business. That's the way the market works.